Hello, everyone. Welcome to today's webinar, Redefine Patterns on Wheels, Empowering Tire Molders Through the Game-Changing Solution by UnionTech. I'm Julia Steiner, Content Specialist at 3DNatives, your media platform for all things 3D printing. And today, we'll be exploring how 3D printing can help cut lead times, reduce costs, and achieve unrivaled accuracy for the tire mold patterns of tomorrow. So today I'm here with Stanley Leung from UnionTech, and Stanley is a high-performing professional with over 15 years of experience in driving APAC market growth. Through expertise in analyzing market trends and leveraging deep industry knowledge, he has helped pioneer industry applications in 3D printing technology. So really quickly before we get started, to give Stanley a better idea of where everybody is coming from, I'm going to launch a quick poll that you can answer right now with some questions to give some background. So we have, are you involved in tire production or the automotive industry? Do you use resin 3D printing already? And if you have 3D printed with resin, which technologies have you used? So please take a moment to answer those questions. And at the end of our introduction here, I'll go briefly over the poll results. So now I think we can move on to the agenda. Thank you. So today we have a great agenda. So first, Stanley will be starting off with who UnionTech is as a company. Then he'll be diving into the why behind UnionTech and the traditional challenges in tire mold production and why they matter. Then he'll be touching on the what, so UnionTech's end-to-end solution tailored for tire molders, how it works, why it's revolutionary, and why over 150 installations of their tire systems have been adopted in just 1 year. Then he'll be getting into the how this technology works, the real-world insights from UnionTech space, and he'll be touching on some features driving success. Finally, he'll be going into their latest launch for tire molders. And after all of that, we will have a 15-minute Q&A session at the end. So if you have any questions throughout the entire duration of the event, you can put your questions in the Q&A box at the bottom of your chat. And you can also see the questions other people have asked and vote on them if it's really something you want to see answered. So please put your questions there. And yes, before I pass it to Stanley, I want to give a quick little overview of the tire market. So this graphic here specifically just is illustrating the automotive tire market global forecast to 2028 in USD. So the CAGR up until 2028, it's expected to grow 2.1%, up to 21.6 billion by 2030. So you can see there's just a nice steady growth and demand for automotive tires across the world. And Stanley, you could continue. Thank you. Another thing that's important to think about here is one of the reasons that there's such a high demand for tires is it's not just that people need tires generally. There's very specific needs for tires given different kinds of vehicles, different kinds of weather. And this illustration also just shows it's scraping the surface of the diversity of tires that are out there, but just generally there's asymmetric and symmetric tire design. And within those subsets, there's non-directional and directional. But again, there's so many different kinds of tires out there with unique treads that are fabricated to meet specific needs. And so today, Stanley will be diving into how 3D printing technology is helping tire mold manufacturers achieve those demands. So before I pass this to Stanley, I'll just quickly go over these poll results. Thank you for answering those. So for the first question, it looks like 11% of you are coming from the tire production industry, 4% from the automotive, And the vast majority of you, so 85%, are other, so not coming from an automotive background. And out of the people who answered question 2, 57% of you have used resin 3D printing already, 43% haven't, so a good mix of people with experience. And then out of the resin technologies that you all have used, 48% of you have used SLA 3D printing before, 28% DLP, and then the rest have not 3D printed with resin. So I believe that's all for the poll. I can actually share these results. You can take a little look there. I think that pop up on your screen. Sorry, I could have done that before. But anyways, just one final reminder about the Q&A. Please send your questions in the chat, and I will pass it off to Stanley to get started.
Hello, thank you so much. Thank you so much for the introduction, Julia. So let me go to the next page. And thank you so much for the introduction, Julia. And also thank you so much for sharing the statistic and data of the tire market growth to 2028. And now let me share a little bit background about us at UnionTech. We are a global additive manufacturing solution provider with over 25 years of experience. So UnionTech's mission is to bridge distributed manufacturing and mass customization across industries. So a lot of users these days who using UnionTech machine are coming from manufacturing background. We have shipped over more than 15,000 printers worldwide, and backing up by a team of over 150 engineers and scientists. And also, we have been partnered over more than 60 reseller distributors across the world. And with all this, we are able to position to deliver reliable and innovative solutions to serve our customer, our VIP customer in the world. And what sets us apart is all about our all-round ecosystem. We are not just deliver the hardware. We provide one-stop additive manufacturing solution covering hardware, software, materials, and on-demand printing service. So our core including R&D and sales of the industrial grade 3D printing equipment, but also we own our material subsidiary company called Synthetics for material development and pushing the boundary of the materials in order to meet and creating a solution for the niche application as well. And not just about the material and hardware, the UnionTech is the subsidiary company we own in China to offer manufacturing on-demand service for those customers who want to leverage 3D printing into their business, but they don't know how to do it, or they don't want to own the machine, but they want to outsource it and to generate value for their business. So when we look into our flagship product portfolio, we focusing mainly on ultra precision SLA technology. So we have full range to match our customers' need, including the entry level, the Light and Pilot series, and we have our iconic Light 2.0 version, which is very popular and famous for the surface bureau market. And also we have our manufacturing grade machines, including the RA series for the footwear, for the tire, and for the automotive. For customer who is looking for extra large format machine like the 1400, 1800, or 2100, this machine comes with dual and triple laser for the best ROIs. So all these machines are fully tuned for speed, for reliability, and for the top-notch production purpose. And today, we are going to focusing on the patterns on wheels, and we are going to share more about how we are reshaping the tire mold fabrication. Before we go into the details, I want to share some of the context, some of the background about why UnionTech putting our effort in this area and why UnionTech is so successful in this area just in 1 or 2 years' time. We have listened closely to tire molders, including Michelin, Goodyear, and so on. And here's the challenge we have heard loud and clear. First of all, they're facing very intensive market pressure as the numbers of the vehicles developed and also the automotive industry grows, and they have a higher demand on the tire performance. As being said, the tire market, the tire design, and the tire iteration become more rigorous and fierce. And when we speak about the tire, it's not just about the overall performance, it's related to the safety. And when we speak about the safety, the tire tread design is the key to impact to the overall performance. And the mold precision is also very critical because it relates to the tire accuracy, the quality, safety, and the comfortability. But designs are evolving fast and bringing heightening technical hurdles. And since all those molds involve low volume, diverse type, and integrated shape with numerous curve and multiple angle features, it makes precision tougher with traditional machining process. And this relates to the limitation of traditional 5-axis machining because the more the complex design involved, the higher the cost, the more the labor-intensive programming is required. It introduces a low efficiency and limited flexibility. And this is the existing challenging they are facing, and they are expecting a solution to overcome it. And so what if there was a game-changing solution beyond traditional 5-axis machines, which can enable those tire molder have an easy operation procedure, has another route to handle complex master patterns, and also giving them a room for the digital revolution. They show us a very big interest on this possibility, and that is what we are offering. At UnionTech, we are empowering the tire mold industry through our latest launch solution, what we call our A series model, which is designed for the tire molder. It comes together with the high precision equipment 3D printer, a dedicated resin, and also optimized workflow together with the pre-processing platform. I will show more information in the next pages. Before we go into the detail of our product, our solution, and our eyes, let's learn a little bit more about the traditional manufacturing process for making the tire mold. First of all, they need to get the data, and after they get the data, they have to build what we call is the master patterns through the data, including the CNC process, and then they will need to add the steel blade manually onto the master mold in order to form a complete, ready-to-use master pattern for the casting process. And which means they require machining time, they require machining CAD/CAM, programming effort, and afterward they need additional weeks to insert one by one the steel blades onto the master mold. And this will usually take about 2 to 4 weeks time to get a ready-to-go master pattern for the casting. And what if we are able now to build the complete mold with our SLA technology for the base mold and together with the steel blades in one go? Then it will help them to save 80% of time and also improving a lot on the cost efficiency for the entire process. And that is where we come in. And right now, we have over 163 tire printer from our RA series in operation worldwide. This is record from January 2024 to June time 2025. They are running in places like Thailand, Poland, South Korea, Japan, and also various provinces in China, such as Jiangsu, Anhui, Guangdong. This widespread adoption shows the high recognition of our solutions across the industry. And here is a real-world insight from Mr. Wang, which is the general manager of mold manufacturing at Lichuan Mold. And they own more than 20 units of our RA series for the Thai mold production. And they mentioned with the adoption of our technology, it helped them to improve 25% of the operation efficiency from time perspective and help them to save 45 to 50% on the cost for making high complex master pattern for the tire mold. For full video, you can watch the full video link here on the YouTube, and it shows you the entire background about the Lichuan mode and how they are leveraging and how they comment on the UnionTech tire mode solution system. So we have explored the challenge faced by tire mold manufacturer and also the limitation of traditional machining method and how UnionTech R8 solution are revolutionizing the tire mold industry, as well as the volume installation volume so far. But what does all of this mean for tire mold maker? And what we are offering to them? What is the ultimate value they care? And here is what we are going to disclose more. So first of all, we are providing an end-to-end total solution to enhance their manufacturing excellence. And what they care is not about the machine specification. What they really care is about the end result of the print part. And this benefit is not just theoretical, and they have been proven by the real-world applications and already driving a tangible result for our customer. What they really care is about four things. First of all, it's about the quality and repeatability. And this is the most critical aspect of tire mold production. And all the tire manufacturers rely on the precise mold to produce tire with uniform thread patterns, optimal grip, and also consistent performance. And our solution has the capability to eliminate all the variability and ensuring that each mold meets exact specification. So we are very confident on the quality and repeatability. And for the production efficiency, we are using this technology to help them improve and the overall efficiency, involved reduce lead time, reduce the complexity of workflows, and so on. And for sure, because this is not a prototyping machine, it's a manufacturing machine, they will care about the ROI. They will care about how much is the dollar, how much is the money they can be saved by changing from traditional way to now our digital manufacturing way. So all this value is what they truly care instead of just the machine. So let us cover it one by one. And I believe quality and repeatability is one of the most important standards for the tire molder, because they see this machine is not a prototyping machine, or the part they expect to print out is not a prototype or one-time model. It's a manufacturing aid. The better the part they can print, the better the final mold they can fabricate. So when we look into the quality for tire molder models, they would care about the surface quality, they would care about the precision and accuracy, they would care about the consistency from batch to batch, and as well as the reliability. and the stability. And first of all, it's about the surface finishing. Surface finishing is very important, and we deliver a superior surface finish with RA value of no lesser than 3.5 micron, which is exceptionally smooth. A low RA value ensures that the tire mold surface is free from imperfections, reduce the need of post-processing or polishing. And this is not just saving the time, but also maintain a high integrity of the mold design. So what as Binning said, we can ensure the outcome of the print mold from our machine is free from step lines, is in an outstanding surface finish. And the second one is about the roundness deviation. Our printer can achieve unparalleled precision with a roundness deviation just 0.03 mm across any cross section of the mold. This ensures that the mold maintains perfect security, which is essential for the tire manufacturing because they need to assemble at least 8 pieces or 9 pieces to form a complete tire mold for the final production. So the roundness is a very essential criteria to make the final mold become a perfect security. So here we are guaranteed on the surface finishing in RA value less than 3.5 micron and also the roundness deviation below 0.03 mm. And not just about the surface finishing and the roundness, but also the precision and accuracy are at the core of our commitment to delivering high-quality tire mold. There are 3 categories when we are speaking for the precision and accuracy. The first one is about the flat point deviation. Our RA series printer use advanced optics and motion control systems to ensure that over 90% of the drag points have a deviation within 0.08. This level of precision ensures that the thread pattern is accurately replicated and leading to a consistent tire performance. And for the steel blade, we are committed to deliver the deviation below 0.04 mm. And as well as the outer tire deviation and inner tire width deviation is able to manage within 0.15 and 0.1 mm. And all these criteria, all this number is even better than their traditional machining process. So we are for the part coming out from our RA series are able to deliver those excellent service quality, roundness, and dimensional accuracy. And the next topic is about the consistency. They are not seeing this machine as a one-time modeling machine, but they expect the machine is keep running 24/7, 365 days non-stopping. They are continuously production machine. So they would expect a good consistency from machine to machine, from batch to batch, from corner to corner. We run massive evaluation before we launch the product to the market. And we have been record 95.1 of the print mode are able to meet the committed standard. We are speaking to the public. And yes, it's not perfect yet, but it's an ongoing journey by improving the formula of the material, improving the algorithm. So, but 95.1 is a very proud result to the manufacturing solutions, to those tire molders. Okay, so and what are the elements include for this RA solution or tire molder manufacturing system? So it comes with three ingredients or three essential components. First of all, the RA600 is the backbone of our solution. It provides the hardware need to produce high quality time more efficiently, specifically tailored for the time mode production. So it combines high precision, high speed, and reliability to deliver exceptional results. And the second ingredient is about our resin. So this resin is specially formulated for the thermal applications. And the last one is about the software. Our software is not just a simple data preparation software. It's a AI artificial intelligence software which allow the user to do the job in one click, reducing all the learning cycle and enhancing the parameter setting for printing the time mode. So let me go into each of them one by one. From the hardware perspective, our technology advantage shine through. So the designed dynamic switch optical scanning system allowed a seamless switch from different laser spot for precision. So when we print the part in a single layer, they will use a thinner spot for the boundary area, and they will use and then we change to a wider spot or thicker spot for the inner area. So it keeps a good surface finishing while not delaying or extending the printing time. And not just about the dynamic switch optic scanning system, but also the automatic calibrations on our RA series. It reduces all the manual intervention required during the calibration, and because of that, it can improve the calibration efficiency and the uniformity performance from machine to machine, because all the calibration is lean on the machine control instead of the human control. And last but not the least is about our micron level controlling system. So our micron level liquid control system uses a full closed loop test for real-time monitoring, and it keeps liquid variation within 0.01 mm. Because of that, it introduces a very uniform layers and smooth surface free quality across the print part. For the material, our X-tire resin are not just a material, they are engineered solutions designed to meet the specific needs of the tire mold production. We tuned the viscosity, we tuned the accuracy, and also we tuned the light absorption, range, so as to ensure the X-tire resin can deliver outstanding quality results and with very consistent and reliable performance across the time. And last but not the least is about the UT1. The UT1 tire modelers is an automation data preparation engine bundled together with our RA machines. And it will allow the user to just need to import the data, and the rest of the work, including data repairment, placement, generating the lattice structure inside, and creating the hollowed structure, and all the rest of the work is complete automatically by the software. And thanks to this, the operator doesn't need to learn all the knowledge. What is the best orientation? What's the appropriate angle for printing the mold in the best quality way or in the highest successful rate? So all the configuration is already preset inside the UT1, and the worker just need to do the one click, and the software will base on all the large language model to adjust the best orientation configuration and do the work completely. So it reduced manual work, it reduced learning cycle, and also enhanced the U rate and reduced the support consumption in multiple angles. So as what we mentioned, we have the RA machine hardware, we have the material and the software, and together with our preset process parameter, and that it will be able to guarantee, it will make us has the confidence and competency to guarantee our quality to meet the market standard. This end-to-end setup ensure reliable and high performance for the tire master patent model. So let's look into the ROI and productivity, and as well as the comparisons. So here is the here's the quick comparison between the traditional process and the 3D printing process. So if we are going to do the traditional process, it would take about 8 steps, and including especially majority of the time spent on preparing the master pattern, because they need to involve the machining process and they need to insert the steel blade into the base mold manually. It would take roughly 2 to 3 weeks time to complete a fully ready to use master pattern. But now with our 3D printing methodology, they are able to reduce the step from 8 to 7 with much simplified and integrated way to create the quality master patterns. And it would take only 2 or 4 days instead of 2 to 3 weeks. And getting one of the segment of the master mold to be printed with our RA series machines. Here is the picture to show the print time and also the material consumption. So since our software will generate the lattice structure automatically during the printing, so the material consumption for each of the segment modes will be lying between 2 kg to 2.5 kg. And the print time for the tire mold depends on the size, depends on the orientation, but usually will be in range between 19 hours to 38 hours. So that it shows how quick, how fast of the printing process can be comparing to the traditional methodology. And now let us share some of the great news about our new launch of the product to the RA series. So starting from Q3, we are officially launch our new RA product line on top of the RA600, which is our RA900. And this is a bigger and more powerful machine on top of the RA600, and is a good fit for those large or medium-sized tire manufacturer who care about the productivity, who care about time saving, and also expect to push the boundary of the quality from RA600. And there are different numbers upgrade on the RA600 comparing to the 600. So the RA600, it features high efficient production with dual laser. So the RA600 is a single laser machine, and RA900 is a dual laser machine. It means high efficiency in terms of the production, and also the laser come together with variable spot. And on top of the dual laser, it comes with the auto resin field and able to print 4 modes simultaneously in high-speed output. So, and beyond the dual laser, we have improved and designed a new recorder design to enhance the the liquid control system, and also adding the automatic door lock systems for better safety ensuring build on that. We can discuss more about the technical perspective offline if you have interest on the RS 900. But when we look into the productivity of 900, it's very clear that is improved productivity from 600 to 900. The 900 cut full plate single model build time from 19.6 hours on 600 to 9.1 hours. So as Binning said, if you print a full trade with 4 model on 900, it will only consume you 36.5 hours, and each of the mode in average will take about 9.1 hours. So as in long story short, the efficiency or the build time efficiency has been improved for 10 to 20% in general. And the last part is about the quality improvement. So here shows a table, executive tables on the quality enhancement of the RA 900. So including the inner width dimension, outer width dimension, it further enhanced on the quality guarantee, quality bar on the 900 from 0.15 to 0.06. And also for the thread point deviations, on 600, we are mentioning 90% of the functional area are able to meet 0.08, but for 900, 91 to 96% of the functional area are able to meet this quality standard. So I'm not going to flew into all the details, but the more important thing is we officially launched the RS 900, and it empowered the productivity and also enhanced certain part of the quality from the RS 600. So right now, for the tire molder, they have a bigger room of the choice to fit their business models and to improve their business operations for the automotive segment. And this is the summary page. And UnionTech empower the more industrial by helping them generating a new route for the tire mold master pattern production. So our intention is to create a easy operations and also another possibility solution to handle the complexity of the tire mold manufacturing. So right now we have over 161 installations happened in the world, and they are very happy with the result, and we are expanding this solution to more tire molder company. And by the end, what we are offering is not just a single hardware or the material, but we are providing a total end-to-end solution and give them a guarantee, a successful guarantee on the quality, repeatability, and also the ROI advancement through our RA series solutions offering. So that is what we aim to generate value for the manufacturers. So that's all I'm sharing today, and hope you find the information is valuable.
Thank you. Thank you, Stanley, for your presentation. That's pretty incredible. The difference between even the RA 600 to the RA 900, going from 19.6 hours for one mold versus 9.1, that's a huge difference. So that's really impressive to hear. But yes, we can move on now to the Q&A section. So for any attendees who still have questions, feel free to add them now. But I'll go ahead and get started. So our first question, I think, was referring to one of your earlier slides where you had logos of different companies, like different tire companies, and they asked, Are those tire makers you reference all customers, or did you just ask them some questions? So like it was one of your earlier slides. Do you know what I'm talking about?
So some of them are direct user and some of them are indirect user because they have a supply chain and some of them own the factory for making the tire mold. But what we speak with them and we hear the pain point they are facing, and also we also met the tire mold factory, and some of the design is very costly to using traditional machining method. So back to the questions, some of them are user and some of them are indirect user, which means they send their design to the tire mold production factory, and those production factory will choose the best solution for them to make tire mold.
Thank you.
Yeah.
Our next question is, could the RA series printers be used for applications other than tire molds? And like, do you have users who use these printers for anything not tire related, or?
Oh, that's a good question. Thank you so much for asking this. So the application is really depends on the user. So and that this RA series is the flagship machine from UnionTech. The reason is, yeah, it is able to print the master pattern or the tire mold in a very smooth quality. Almost you won't able to see any stair step at all. And so the customer can definitely use the machine to print prototype. But is it really necessary? So that's another part of the question. So the machine, the solution, yes, they can be used for other applications. But right now, for those customers who adopt our series are purely interested on the tire mold fabrication.
I see, thank you.
Yeah.
Our next question is something that you did end up talking about. But the question is, how long does each print take? What is the layer thickness that the molds are printed in? And I know you talked about that a bit already, but maybe
Yes.
yeah.
So it really so there's different type of size, different type of mold. Sorry, there are different type of tire. You have the summer tire, you have the winter tire, the snow tire, or the tire for the passenger car, or the tire for the truck. So the size of the tire is different from product to product. And the print time is really depends on the size of the tire mold. But in general speaking, I would say the print time for the tire mold is in between 18 hours to a maximum 30 hours in maximum. Based on the benchmark we have been done so far, we have done over hundreds more benchmark already. So based on this benchmark experience, in general speaking, the print time per each of the mold would lie in between 18 hours to 30 hours. And we are using 0.5 at 0.05 mm per layer. So that is the best layer thickness we decide to go with. And that gives the very satisfactory result in terms of the quality, in terms of the print time, in terms of the successful rate to the tire molders. And so that is the total solution we're offering. So the configuration, the layer resolution, also together with the material formulations and so on.
Thank you. The next question is, how does the RA900 do automatic resin filling?
So there's a tube connecting to the build bath, and there's a sensor. It will detect the threshold level of the resin, and then to fill it in automatically to the build bath.
Okay, thank you. Our next question is this technology then competing with the current solution of 3D printing the stripes? For example, the famous case study from Michelin. I don't know if you're familiar with it or not, but if you are, maybe you can speak to it.
I'm not very familiar on that. I'm not very familiar with
Okay.
that. Yes.
But yeah, maybe is it competing with other types of 3D printing being done for tire production?
Sorry, can you repeat the question again?
Just maybe talking about how UnionTech's 3D printed tire mold solution. Are there other ways that 3D printing is being used to create tires that are competing with UnionTech's?
Competing with UnionTech. I'm not sure I get the question clearly. Would you mind to answer in?
Yeah,
Yes.
I can ask another question. No problem. So somebody else asked, can you speak to how your material holds up to wear? How does the life of the mold compare to metal? So how long do they last?
Oh, it can be last for a year. So if you keep the machine or including material in under our instructed conditions, the material can be last for over a year. Over a year. So there's some criteria. For surely not to put the resin under the sunlight or under very hot conditions. So if everything is managing with our recommended conditions, it can be used for pretty long time.
To go along with that, somebody asked, how many times can each 3D printed mold be used for? Do you have like a number of how many times it can be used, or is it more of like a duration of time kind of thing?
So it can be used quite. We didn't mention about that. That's a very good question. I think about. So first of all, it's not sacrificial models. It's not a sacrificed models. So the model is used to make a silicon mold or whatever. So after you make the silicon mold, the master pattern can be reused again. So ideally, it can be used for many times. Depends. Any damage will be happening during the transferred process from the master mold to the silicon mold.
I see.
Yeah. But
The
another
next question
question is usually for the tire molder they are they use the part for one-time usage only because by the end they will create a metal mold, and what they need is the metal mold.
Another question we have is how much resin is consumed in support volume compared to the actual mold printing?
I don't have the record, but I guess it's always. I think the audience today is really a professionalist from this market. We don't measure it, but I guess it's about 5% or less than 5%. So the reason why is we are using a top-down printing methodology. So the support is not that many. First of all, the support is not that many, and also when we build the part the inner structure is hollow structure. So which means the overall weight or material consumption of making this mold is further optimized. So if we look into the support consumption, I would say is about not more than 10%, or even just in 5%, comparing to the overall modeling.
Thank you.
Yeah.
Another question we have, oh, yes, and I'll make a comment as well. If there's a question you have, if you ask it not anonymously afterwards, Stanley can email you with a question if it's something he can't answer directly right now. So it helps out if you don't ask the questions anonymously, because then we can get back to you later with an answer. But yes, okay, I will ask another question. So with automated workflows using AI, how does the automated intelligent workflow achieve a 95% reduction in manual work? And what tasks still require human intervention?
So we can that's a good question. Usually the most challenging part on using 3D printing, or for the operator level to using 3D printing, is they need to learn about the knowledge, learn about what is the right orientation to place the part for the printing, and how to generate the hollow structure. What's the wall thickness of the hollow structure, or the wall is creating the best result. And what is the lattice structure? What's the size of the shell and prefer for printing the part? So learning those knowledge is a pain. And our software is built to eliminate all this learning cycle, because when the user import the data, their STL data into our UT1, and instruct the UT1 software that I'm going to print the tire mold, and the software will, based on the shape, the curve, the size of the mold, to generate automatically to generate the hollow structure, generate the lattice structure, generate the support, and also adjusting the orientation and the angle. And all this knowledge is not required for the operator. And by eliminating all this, it saves them a lot of time on learning, on try and error, and on taking risks for placing or making a wrong orientation or angle. So with this automatic software, or what we call UT1, it helped them to save a lot of time on orientation, generating all these internal structure, generating the support, and learning all those knowledge. So that is the objective of the software, and that is a very powerful tool and powerful engine right now for the time orders.
I see, thank you.
Even though they find a junior operator, they don't need to worry about whether there's any additional charge or learning cost they need to spend onto the junior operator, because all this configuration is already integrated into the software, and the software will do the job and find the best way to print the part from the database.
Thank you. Our next question is, can tire molds be printed on light 600 printers?
Okay, so seems like this question is asked by one of our light 600 user. Okay, thank you so much for your questions. My short answer is unfortunately no, because the hardware and the configuration is completely different. It's completely different. You can print the tire mold, but the quality is not at the same bar of this market need. Yes. So printing is one thing, but the quality standard is another very important recipe of the RA600 or RA900. So if your intention is to serve time order, I think right now the RA series is the only solution to hit their standard bar.
Thank you. Our next question is there consistent demand for molds? Are multiple replacement molds produced in a production run, or is this mainly used for new mold development?
Not just for the new mold development. So once you have the part, you can use it for making the new mold. You can use it for focus group evaluation and also phototyping evaluation. By the way, that's a product. Before they finalize the production of this product, they still need to run through the standard evaluation process. They will need the evaluation mode. They will need to send the part to the principal customer for validation and so on. So it's not just for new tired production. It can be used for different perspectives on the production product development cycle.
Thank you. Our next question is, how many industrial SLA printers does UnionTech sell in the USA or Europe every year, or are the printers mostly sold in China?
Wow, that I don't so first of all, I'm not sure I get the most accurate data point for these questions. Since I'm in charge for APAC, I might know a little bit better on the APAC, but for the installation status for US and Europe, I might not be the right person to answer. If you don't mind, you can send us an email, and then we can have the right focal point of the contact to reaching out and then to get back to you on all those installation status. Yeah.
Thank you. The next question is, I assume you are using 355 nm resins. Is there a drive to use 385 or 405 nm based resins to be polymerized by DLP or other exposure systems like MLP? If that question, I don't know, was that clear to you?
Why not? Why not? So we are always exploring the possibility on different types of resins. So there are different characteristics of the resins, and I know that our R&D team, especially on the material development team, is very interested and putting a lot of effort to work together with our third-party company or our partners and to try to expand the possibility of our resin choice in our machine. So why not? Definitely. But I also understand there are some limitations from 305 or 405 to SLA technology. So there are some technical challenge need to be overcome. But I think there's a possibility. And if you have a good solution, or if you have some recommended materials which we can export, develop, send us the information, and we will bridge you together with the R&D team and look into the collaboration opportunity together.
Thank you. Well, we're just about at time here. Thank you all so much for joining today and for your participation. We had so many questions, which is awesome. Stanley, thank you so much for your presentation. This webinar was recorded and it will be available on the 3DNatives website in the coming days. And for anybody who asked questions that we didn't get to, I'll be sharing them with Stanley so he can email you with answers. So thank you all so much for
Thank
your
you so
time
much.
today.
Thank you so much, Julia, and thank you so much for all the audience today.
Thank you. Bye.
Thank you. Have a good day. Bye-bye.